Welcome back to another ggplot tutorial here at the Data Digest. Today I'm going to show you how to use the different geom_line and geom_path function arguments. I will use these for several examples, like the evolution of popularity in baby names, the Beveridge curve that shows the relationship of unemployment and job openings during recessions and expansions, the Russia campaign of Napoleon, and the use of geom_line in Cleveland dot plots. Let's start with the R code. After loading several packages, we can create a basic scatter/line plot in R like this. I loaded some Bitcoin data from GitHub and transformed the date character column into an actual date column, and then I only show the last 10 values. And since the connected scatter is a hybrid of a scatter plot and a line plot, we have to add the geom_line function at the end to connect the dots. If we use more data points, so the complete data set, then it almost looks like a line already, because the dots were much closer to each other, but we can still connect it by adding the geom_line. Similar to geom_point, you can change the color of the line and the size, so the width or thickness of the line. Be aware that the order of these different geoms matters. If you plot the dots first, then the line will be on top of the dot, but if you reverse this order, then the points will be on top of the line. If you have some exponential growth, it's advised to use a log transformation on the y-axis, and you can do that by adding the scale y log10 function, and then also from the scales package use the $ argument for labels. So now it's a bit easier to see the changes that happen throughout the years. Some other cosmetic changes we can do is to use the theme black and white function, and also for geom_point use some light gray in the background, which the geom_line then overlaps. If for some reason you want to change the orientation of the axis, so put the date on the y-axis and the $ on the x-axis, you have to be aware of the following phenomena. ggplot tries to connect the dots based on the x-axis by default, so it looks for increasing values of x and then connects each y value that appears. And if you want to prevent this, you have to specifically say for geom_line that the orientation is now y-axis and that it should connect the dots in this pattern. And then you would get this result, where it now moves according to the date on the y-axis connecting the points. I will now discuss the different function arguments for the geom_line or geom_path functions that you can look up with the help or the question mark function. For this I created a test data frame with the numbers 1 to 5 for x and y and a type column that I will use later. But for a simple line plot, you tell the ggplot function what the data frame is and how you map the aesthetics, so the x and y values, and then you add the geom_line. First I changed alpha, color and size within the geom_line function by explicitly stating what the size, so the width or thickness of the line, and the color is supposed to be, and with alpha 0.5 you increase the transparency and now see the grid behind it. Instead of using fixed values, you can also map these function arguments to a variable of the data set. That's why I included the type column. And if you perform an aesthetics mapping to the type column for size, you would get the following result. So A is a bit thinner than B. If you perform the mapping on color, you will see that you get two colors now, one for A and one for B. This would be a bit easier to see if you increase the size to 2. And if you also use the grouping variable within the mapping, you would force the line to continue. So now geom_line doesn't consider A and B to be separate lines, but part of one group, but it will still color them differently based on type. And similarly to color, you can also map alpha to type and then get two different values of transparency. You can also map the value for size and alpha and color to a continuous variable that's part of the data frame. So when you map it to the y column with increasing values from 1 to 5, you get different areas of line width. You can also match it to a continuous variable of color. So now it increases from 1 to 5, getting brighter. And if you want to use 1, 2, 3, 4, and 5 as factors, so different categories, you would have to say that it's part of one group. Otherwise you get no line at all. And then you would have 4 different colors. The same happens if you map a continuous variable to alpha. It produces different levels of transparency and a kind of grayscale. If you want to change the line type, You can do this either by calling a number or the name. So if you would set this to 1, you get a solid line, and you could also call it solid. If you choose 0, it would be blank. If you chose 2, you get a dashed line. 3 will be dotted, and you can use dot dash or type 4 for a line with dashes and dots. This is an example of all the line types that are available to you, from solid to dot dash, dashed, blank, and then some more unique patterns. Another thing you might want to change for your line as it connects different dots would be the line join function argument. You can set this within the geompath or geomline function to round, miter, or bevel, and then you get a round corner, a pointy one, or a leveled one. And lastly, there's an option to also talk about the ending of the lines. You can set this to but for a sharp ending, or you can choose line and round for a rounded curve where the line starts and ends. Let me quickly visualize the difference between geompath, geomline, and geomsteps. In this ordered data frame, I simply have the values 1, 5, and then 5 to 8, with 6 repeating, and a group variable. And if you use geomline, you get the same result as geompath, because the x values are ordered. And if you use geomsteps, then it will not connect the lines in a direct way, but in a staircase type of way. When I create an unordered data frame where the x values don't increase smoothly but have some jumps from 1 to 4 and then down to 2 again, the differences for geomline and geompath are as follows. Geomline will force to connect the y values by ordered x values. So it will ignore the order of the data frame and simply go from 1 to 2 to 3 to 4 to 5. If you use geompath, it will respect the order and go from 1 to 4 and then to 2 and then to 5 and back to 3 and look up the associated y values along the way. Geomsteps, however, behaves like geomline but without the direct connection. If you include the group variable in aesthetics mapping, it will only connect points to a line that belong to the same group. So for group A it will connect 1 to 2 and 2 to 4, and for B it will be between 3 and 5. And for geompath, it will again respect the order, going first to 4 and then to 2, and geomstep creates 2 lines according to the groups. Let's now use these functions for some examples. When you load the baby names package, you get a summary of male and female names from the US over more than 100 years, with n giving the actual numbers of names registered in that year, and with prop displaying the percentage or proportion within each year for that name. In this example, I filter for Amanda and Ashley as names, and when we only look at the data from 1920 onwards and we map a color to the names within the ggplot function, we can add the geom line, and with size equals 1.5 we make the lines a bit wider. And here we see that Amanda was more popular than Ashley for a while, and then slowed down and Ashley overtook and stayed more popular for the next decades, but more recently both of these names became less and less popular. A second option how we can display this data would be with connected scatterplots, where starting from the year 1971, with this representation we see that Amanda was more popular than Ashley until 1983, where it was overtaken, and then, as I said, Ashley remained more popular, but both diminished in popularity towards 2017. And when we want to build a plot like this, we first have to turn the data from a long format into a wide format. In the long format, we have information for both names twice for each year with the respective count number. But if we want to plot Amanda on the x-axis and Ashley on the y-axis, we have to turn it into a wide data frame. Because now after spreading it, we have the n values included under the name columns. And you can accomplish this by using the pivot-wider function, where you can choose the name from the name column and the values from the n column. That's all the pivot-wider function needs. Let's generate this plot step by step. First we assign Amanda to the x-axis and Ashley to the y-axis, and we keep the label year in the background. So we have a year column and we can already map that within ggplot and use later with the geomText function. Then we can add geompath to connect each dot to the next. And as a reminder, if we would have chosen geomline instead of geompath, it would have connected the dots according to the x values and not by the order of the data frame. So what we want to do is connect from year to year, which would happen with the geompath function. But if you use geomline, it will order the values with increasing x-axis values, which we have for Amanda. And you can see that for the first 13 values, Ashley increases, which is represented here, but then you have a drop to small values for Ashley, then it goes up and down again, and this would happen if you use geom_line. If you want to use the order you have in your data frame, you have to go with geom_path. And as another reminder, geom_step behaves like geom_line. Next, I wanted to add the year that we set as label before, but I only want to show every other year, and I also want to move it slightly to the right. And there are two ways how you can skip every other year. You can ask, if I divide the year by 2, will there be 0 or 1 as rest? So the percentage acts like the modulo function in mathematical operations, and it will ask if there will be a remaining rest. So this is the pattern you get if you divide by 2. For 1971, 1 will be remaining, and you can ask if it's 1, and then you get it true. Another option would be to turn this into logical, and then 1 would be translated to true and 0 to false. So then you can turn this data white data frame into an odd years data frame by filtering for this operation we just did. And then when you add the geom_text function, you say that the data is now not the data white that you pipe in the other functions, but you say the data is odd years, and then it will skip the even numbers. The last things that I then did to create this chart was to horizontally adjust the text to the right, with -0.2, and also add a diagonal with the geom_ab line, where you can say it should start at the 0 intercept of the y-axis and have a slope of 1, so 45 degrees increase, showing that whenever the points are above the line, Ashley is more popular than Amanda, and below the line, Amanda is more popular than Ashley. And for line type, I choose dashed. When you go to the data2wiz.com website, where I saw this example, you see that you can add little arrows in between each of the line segments when you use the function geom_segment instead of geom_path, and then use some extra functions to indicate that you want to go from one point to the next, and then you can use the arrow. But if you want to keep it simple, go with geom_path. There are some potential issues or caveats with this kind of representation that I quickly want to talk about. I link to the article and website in the description below. But look at this example from the New York Times, where on the y-axis you had auto fatalities per 100,000 people, and on the x-axis you have miles driven per capita in cars. And you can see the evolution from 1950 to 2011, with the number of fatalities going down, even though the numbers of miles driven increased. And you can see that some information was added describing the reason for some of these changes. So kind of nice representation. And on this website there was some critique or discussion of this kind of representation, whether it's useful or whether it can be confusing. And if you want to look at the individual stories, a regular representation with the years on the x-axis and different kind of statistics you want to show is more easy to follow. So the miles driven per capita increased steadily, and the fatalities per capita increased and then decreased. So both of these trends would be easy to discuss. And if you merge them together, it can be a bit difficult to remember what's going on when the lines go down or sideways or diagonally. So if you use this kind of representation, make sure that the audience understands what's going on. And as I said, feel free to learn more about this kind of representation in the link below. In the next example, I want to show you how you can create a Beveridge curve. It's a graphical representation between the unemployment rate and the job openings rate. Changes in the supply of or demand for labor causes movements along this curve. It was named after the British economist William Henry Beveridge, and it's a good example to show how you can use different colors for the phases of recession and expansion. And I will show you how you can create a chart like this right now. I downloaded the data from the US Bureau of Labor Statistics, and I added a column that represents different phases over the last 20 years. And I called this range, and in parentheses I wrote whether that's a recession or an expansion. As a start, you can pipe the data set into the ggplot function, put unemployment on the x-axis and job openings on the y-axis, and then simply add the geom_path. Then I include another column in the aesthetics mapping by setting the color function argument to the range column, which will lead to different colors along the path depending on the value of the range column. And I also added points at the geom, and once you do the mapping within ggplot, it will use the same color for path and for points. There are 3 issues now with this chart. Once you see there are gaps between the different colors, so from one phase to the next the line disappears for some reason. Also, the order is now alphabetical and not chronological. It goes DJM according to the alphabet, and the 2001 recession in the legend is on the last place. Also, the legend being on the side takes a bit too much away from the plot, so I tried to put it on top of the chart. Okay, so to fix the legend issue, you can say that the theme legend position is supposed to be top, but then it spreads the names of the range over one line and then it gets too wide again. But you can make use of the guides function and say that you want to have it in 5 rows, and then you get a graph like that. Regarding the order of the factors, when you look at the values you have in the range column, they are in the right order, but within ggplot they will be turned into alphabetical factors, so we have to turn them into factors ourselves with the right order like this, because currently the values of range are simply characters and not factors yet. All we have to do is do a mutate on the range column, where we say that range is now a factor and the levels we want to use are the unique values from this column, and those were, as you remember, in the right order. Then you can rerun the code and the colors change now, but the order is correct. So first red, and then the recession in this brownish green, then the light green expansion going up, and then the 2007, 2009 recession and another expansion. What can we do about the disconnect between the different time ranges? That is also easy to fix by simply saying that yes, you want different ranges for color, but the group is supposed to be 1. If you force this grouping to 1, then each line is connected to the next and the gaps disappear. There's one more thing I want to do. I want to add some kind of orientation about in which year each of these dots is. And you can see there is information included in the month column. So I use this for label within the ggplot function. And then for geom text, I again only do a selective labeling by filtering the data frame in a way that I make use of the string detect function, looking for the pattern January in the month column. So only when there is a January in the month column, this text will be used to label this graph. And then it would look like this. And if you zoom in, it's actually not that bad. You see this is January 2001. Then this area is a bit overcrowded, but here January 2009 and then 2010, 11, 12, 13, 14 is a bit more clearer. Next I want to show you how you can use the geompath function to visualize Napoleon's march on Moscow in the year 1812, including a visualization of the army strengths, so the size of the survivors, as well as the color representing whether it's an advance or a retreat. This is based on a map created by Charles-Joseph Minard, who was a French civil engineer who made significant contributions to the field of information graphics. And one of these infographics is the map of Napoleon's Russian campaign, where he included the coordinates of different cities, the strength of the army, and even the temperature during certain dates of the campaign. The map is based on 2 data sets. One is called troops, and it has longitude and latitude information, as well as the strength of the army and the direction, A for advance, R for retreat, as well as division information. There were 3 different divisions involved in the campaign, and city holds the name of the city and again longitude and latitude. The first thing we can do is to plot the movement of the troops. So that's the data set used, with the x-axis holding the longitude and the y-axis holding the latitude information. And then for size we use the survivors column, for color we use direction, and for grouping we hold the division information, so that only the coordinates within each group get connected, and then we join the lines and end the lines with the round option. For the city location we have to use the city data frame, which also holds longitude and latitude information, and we set label to the city column, and with geom text we make use of the label information included in the aesthetics mapping of the original ggplot function. I vertically adjust the text upwards, and then I also add geom points on the coordinates. If you want to combine both visualizations, you have to make sure that you specify what the data is. So in the original ggplot I used the troops data with everything we used before, and then I add geom text, but now based on the city data, and now I have to do the aesthetics mapping for that data frame, and the same then for the geom points. If we save this object in a variable called plot Minard, we can continue to adjust the layout even further. So a few things that we can do. For example, we can move the legend in the bottom right corner. We can give it a title, label the axis with more details, and choose different colors for the direction and a different scale for the survivors. And here I specified the breaks before to show 50,000, 150,000 and 300,000. So if we run this, we get the specified colors, a dark gray and red, the legend in the bottom right corner, and the breakpoints now at the intervals that we choose before. There is a fancy version of this plot created by Andrew Heiss, who has his own YouTube channel with many more informations on visualization, and he created this original map pretty accurately by matching the colors, adding the cities as well, and then even making use of Google Maps to place the campaign on a map of Europe and then have a better looking background, and even including the temperatures of certain cities, which was one of the reasons of this shrinkage of the even retreating army, that it was sometimes minus 30 degrees Celsius. And I link to his code in the description below. As a final example, I want to show a version of the Cleveland dot plot, and I want to go back to the baby names example and show the most common 20 female and male baby names. How did they change over 30 years from 1985 to 2015? Did some become more popular now than they were in the past? And did some names become less popular? So the first thing I did was to filter the baby names dataset for female sex and only included the years 1985 and 2015, then grouped by name and added up the numbers that were assigned in these 2 years for the respective names. Then I arranged by decreasing total, and the result would be this. Most common name in these 2 years was Ashley, then Jessica and Jennifer, and we have over 25,000 values of decreasing names to very rare versions. So if I want to store the 20 most common ones, I could make use of the top n function and then select the name column, unlist it and store it as a vector. And the top 20 female names would then be stored like this. I repeat the same for the top 20 male names from these 2 years and store it as a vector. Then we have names like from Michael to Jacob. And now I wanted to plot this information, but I got some weird patterns. So now I go back to the original data frame, but filter only for the names that are in these most popular vectors now. Then I make a plot with n on the x-axis and names on the y-axis, and I wanted to facet wrap it by sex. So only have female names in female column and male names in the male column. For the color of the dots, I can choose the year. So 1985 is represented by red colors and 2015 by blue. And the geom line is supposed to connect these dots by grouping the name. And the reason for this weird behavior was that if you look carefully, you find that there are a few mentions for female most common names Daniel, Matthew, David. So some male names made it into the female category and vice versa. We have some male names Emily, Sophia, Emma and Elizabeth, so we have to apply one more filter. And the filter I included was, yes, to look for the most popular names, but only be very careful to only look for these names in the female category and for the male names only in the male category. And I made a subset of these two data frames by row binding them because they all have the same column names. It works perfectly, and I called it top 20 names from 1985 to 2015. And now if you plot this, you see that there are no dots anymore. For example, for William in the female column. And now if you want to get rid of the empty space, within facet wrap you can say that the scales of the y-axis should be free, and now it will only fill the names where there is data. And then the last thing I did was to put the legend on top, and with labs color equals year you can change the title of the legend because the color assignment was based on this column. Let me spend 1 minute on interpreting the result. You have some names that remained relatively stable or even increased, like Jacob, William, or Emily, Elizabeth. And then were some names that gained popularity over the years, like Olivia and Emma. But most of the names that were popular in 1985, like Jessica, Jennifer, and Ashley, or Michael, are now less popular, often by quite a big margin. So I was curious what could explain this overall trend. And the first thing I checked was to see if maybe the data decreases over time, but you can see that we actually have more observations going from from 1986 to 2016-17, or at least it remains relatively stable. Same for male names, number of observation increases and then remains stable. But what does indeed happen is that over the 30 years for female names, we have an increase of names chosen from 12,000 unique ones to 19,000, and also almost a doubling for male names. And of course, if you have more names to choose from, then the numbers assigned to these popular names will decrease, and you will have more and more names with lower numbers. This tutorial was less technical and more example driven. So you now know about the difference between geom-line and geom-path and how to choose different sizes and colors to visualize your trends of the data. Hope you found that informative, learned something, and will make use of it in your own plots. There will be another video next Monday. I hope you will join me again here at the Data Digest.